Hello class, I wish I could be with you in person today, but this video will suffice for now. We are going to be moving into the second process of the water cycle that we are covering this year, and that is condensation. So if you remember prior to now, we were really talking about evaporation, which is the process in which liquid water gains thermal energy and therefore gains energy, moves faster, spreads out, and can escape into the air as water vapor. This process, condensation, is the exact opposite. Now, as we're going through, you'll notice that your notes this time are a big chart. You, in your self-awareness of what's already in your head versus what maybe is new, or that is really kind of a refresher on something that maybe you used to know but you kind of forget, you're going to decide where the information goes as we learn it today. If it's something that you already knew, you're going to write a fact and maybe draw a diagram or a picture or put an example over here in one of the blanks. If it's another main point that we talk about today and it's something that's new that you really didn't know before or expands on something a little further than what you knew before, it's going to go in this blank where it says what I learned new today. And so those are the two areas of the chart you're going to be filling in. You should have enough room on the chart. If you don't, you may definitely go to the next notebook page that's blank and just fill in and kind of create the chart again on that page and fill in what else space is needed. So the first fact that we're going to be talking about is kind of the definition of what condensation is. So just like evaporation, it is a process in the water cycle. This time though, it's water vapor losing thermal energy to the surroundings, that could be the surrounding air, which makes the water molecules kind of slow down, they get closer together, and because water likes to join with water, it has that cohesive property, they stick together, they cohere together. And those just, once we get a bunch of molecules joined together, then we have a tiny water droplet. The next fact is that condensation is a warming process. So I like to think about the real life example of a humidifier. Now, in Mrs. Harding's home, I have a humidifier in my basement that looks just like the one pictured on the screen. A dehumidifier is something that takes the humidity, the water vapor, out of the air. De means from or away from. So a dehumidifier will take in, it sucks in the air, and it cools the air so that thermal energy is lost. So the water vapor that did have a lot of thermal energy is now slowing down and kind of cohering together, and it's changing back into liquid water. So it's actually dripping down. And this bottom drawer, I don't know if you can tell right here, but there's this bottom drawer right here. After it has been running for a little bit, we have to empty out this bottom drawer because all of that water vapor that has been slowed down and cohered together, forming small water droplets, is filling up this bottom drawer with water. So then what it does is it blows out the air, the air back into the room. And you might have noticed if you have a dehumidifier that near your dehumidifier, the air is actually warmer. Why? Because we have the water vapor slowed down and lost that thermal energy to the air, and it turned back into water, and the air is blown back out into the room. So that thermal energy that the water vapor lost is in the air that's blown out of the dehumidifier. So that's kind of how that works. Feel free to take a second. You might even want to draw, if you learned something new about a dehumidifier today and how it shows that condensation is a warming process, you could draw a diagram here and put arrows showing the air going in. The temperature inside is dropped, which means the thermal energy is lost. The water vapor drips down into this bottom pan as water droplets. And then an arrow going out, showing the air is pushed back out and that it's a warmer temperature when it leaves. Next thing. This thing's a little confusing, okay? And basically all you need to know is that condensation and evaporation really take place at the same time, okay? And I think you might already know that because when we talked about saturation the other day, we talked about a sponge. And in that sponge, it becomes saturated when it becomes so full of water it can't hold anymore. Well, the only way it can hold more is for it to drop some of the water out, then more can go in it. And we kind of drew that in one of the pictures, I think, on your foldable in your notebook. And this is kind of like that. In order for evaporation to take place, condensation has to be happening at the same time. However, sometimes it's at different rates. Depending on the temperature of the water, the temperature of the air, it happens at different rates. So, one thing that you need to know is, if you're shown a picture, like the one up here at the top of the screen, would you tell me that this is condensation happening? Or would you tell me that it's evaporation happening? You want to look at the arrows. I have these purple dots on the screen that are like water molecules. The water molecules, there are 1, 2, 3, 4, 5 that are entering the water. So I have 5 water vapor molecules that are losing thermal energy and re-entering as a liquid into the water. But then I have 1 liquid water droplet that's gaining enough energy to escape from the water as water vapor. So what would I say here? I would say that this picture is showing condensation even though evaporation is taking place at the same time. My reasoning would be that more condensation is happening than evaporation. So, how do we know that evaporation and condensation can occur at the same time? Well, I'm going to show you a short video clip of how we know this. And in class, sometimes I use a fish tank to demonstrate this. So after you're done with your flipped video and filling in this chart, you could walk to the back of the classroom where I have the fish tank and observe how there is water in the bottom of the fish tank. And there are also water droplets that are formed possibly on the glass, but also at the top on the plastic wrap that's covering the top of the fish tank. So here is the video clip. All right, moving on to the cool stuff. How do clouds form? On this slide right now, I am going to go through the steps of how clouds form. However, if you want to wait to fill this in on your chart, I'm actually going to show a picture that kind of helps explain it on the next slide. So we'll come to that in a second. So, water vapor is in the atmosphere because evaporation of the surface water on Earth has already taken place. So we've got this water vapor up in the atmosphere. And it's rising, rising, rising. Well, if you remember, the higher we go in the troposphere, the temperature decreases. So, the air cools to dew point. Now remember, we have to think about what dew point means. Dew point is a temperature when the air is saturated with water vapor. So, this air has risen, the temperatures have dropped. Colder air cannot hold as much water vapor. So, it reaches 100% relative humidity for the temperature at the top of the troposphere. It's saturated, cannot hold any more water vapor. That means that the temperature is at dew point. So what happens then? These water molecules condense. How they condense is this. They've lost thermal energy because now they're colder at the top of the troposphere and they're slowing down. As they're slowing down, they get closer together and the water molecules actually join together. This is cohesion. Then, the last step here, those water molecules that have slowed down and some of them have gathered together to form a small water droplet adhere to solids in the air. Now remember a few weeks back when we talked about the atmosphere, we talked about what are the things in the atmosphere. There's gases, there's liquids, and then there's also solids. Those solids are things like smoke and ash and dust and soot, dirt, and there's sea salt. So there's all kinds of solid particles in the air, and these tiny water droplets that are in the air start adhering to these solids. Now, the specific name for those solids that you should know is that they are called condensation nuclei. Those are the things that the water droplets adhere to. So the smoke, the ash, the dust, and the soot. Now, here it is in picture form. If you start at number 1, it says that warm, moist air rises from the surface of Earth, or near the surface of Earth, and it cools as it rises. And we know this because the troposphere gets colder as you go higher in it. The next thing that happens is that the air reaches dew point temperature, which means it's completely saturated with water vapor. Condensation begins. The water vapor particles start slowing down, getting closer to each other. They cohere together, making tiny water droplets. Then last thing, these water droplets condense onto solid particles in the air, which that whole process causes what we see as those white, fluffy clouds. Sometimes they're not white, sometimes they're dark, but those clouds in the sky. So, right now I'm going to do a demo and show you exactly how a cloud forms. Alright guys, so here all I have is some really warm water. And above that warm water, okay, so there's a lot of water vapor probably rising up above the water. Okay, it's gaining some thermal energy and it's releasing water molecules as water vapor. Then I'm going to make some smoke. And I'm going to put this frozen mug above this hot, steamy water. I'm going to blow out my match. And I want you to watch. Look at the cloud forming. Okay? And this is all because we have warm water vapor air rising, but then this frozen mug is cooling it down. That water vapor is cohering to each other, but then also adhering to the smoke particles. And it's creating, if you can see inside the jar, a cloud. Okay? And that is how a cloud is